participants. So looking to see how many of that 180 are joining us right now. Please keep your webcam off and your microphone on mute, except in the breakout session when we want you to turn on and interact with each other. And please post any comments and questions in the Zoom chat that we'll be monitoring to interact and relay to our panelists. So I'll now pass over to Stuart Phinn, past President of Earth Observation Australia, who will introduce today's webinar topic. Thanks very much, Stuart.
Thanks very much, Megan. Welcome, everyone. Before I start, I did want to acknowledge the traditional owners of the land and waters on which we're meeting and also on which we're working across Australia, and pay my respects to their elders past and present. I'm going to just do an introduction to the topic today, and then we're going to run through a set of activities engaging with everyone in the audience about Earth observation analytics hubs and what we think they are and where they're going. And then we're very fortunate to have a very high level group of people who have extensive experience in a range of different areas around Earth and space observation in terms of setting up and running these types of capabilities or facilities as well. So just to illustrate what we're talking about today, I'm going to share my screen to start with as an introduction. I know a lot of you do understand what Earth observation actually is, and I just wanted to get us on the same page for this discussion. It does involve collecting forms of data about the surface of the Earth, its atmosphere and other ecosystems, and then applying a range of operations to transform those data into measurements or observations, which can then be used for a range of activities, whether it's scientific purposes, in terms of developing and implementing legislation in government, or for people making decisions in private industry and defence operations. The key part of, I guess, going from satellite data as a picture or relative information is really those orange arrows when we bring in data sets, correct them, and then are able to apply algorithms to them to map targets or estimate quantities in them. And we've seen really rapid developments in the last 5 to 8 years in our ability to bring together the data sets, so the image data and the products, as well as putting them next to quite high-end compute capacity, and then the ability to interact with those two things together to push out products and services. So today is very much about how we approach those two orange arrows and looking at it across our government communities, our sort of university communities, and also private industry as well, as this is a very interlinked space in those areas. So where we're going to is, how do we support something like this operating stack, as you can see on the left there, so that we can more effectively go from data to delivering, I guess, products and services to start making decisions from. So we're somewhere in the middle here today. So having said that as a preamble, what we're going to do now is actually get into some initial discussion. So we're going to ask questions and then have a slightly separate small breakout group to begin with. So we're going to run a Zoom poll to begin with. And I think, Larissa, if you're able to bring that first poll question up, please, that would be really helpful. So simple question that you can see there. Do you know how to access and use data analytics, Earth observation data analytics hubs and services? So we'll just let that run for a minute and see. And just to start running through this, we're going to hear from our panel later on about what's happening at a Commonwealth government level with things like Digital Earth Australia, what's happening with other broader initiatives like the Open Data Cube, but we're also going to hear from specialised data analytics or analysis facilities like the Australian Space Data Analysis Facility as well. So there's a big choice out there. What do they do? How do you interact with them? It is a bit of a challenge. So looking at that poll that we've got there at the moment, looks pretty stable. Looks like we've got about a fifth, 21% saying, yes, we get it. The majority of people would like to know more about them as well. And that's good. That's partly why we wanted to do this, because I don't think anyone's across all of these areas completely. So thanks very much, Larissa. I'll just move that off. Cool. All right. The second question, which we'd like to do via a response in the chat window that's on your screen, is how do you think these Earth observation analytics hubs and services can help you in what you're doing as your core business? So, in the context of Digital Earth Australia, is it Google Earth Engine, the Australian Space Data Analysis Facility? What is it that you actually want from them to help I guess deliver what your core objective is? If you're a very focused startup and you have a product which is going to be used in a certain industry, basically to assess and track the status of infrastructure, could be I guess power supply infrastructure. What is it that you actually want out of that hub? Is it data? Is it processing capability? The ability to distribute your results widely? So have a think about that, and in relatively simple terms, if you want to type that into the chat window, and we're essentially going to use that in one of our later exercises in terms of going forward. So what do you actually want out of, I guess, an analytics hub to support your work? And that could be services, could be education, could be training, could be access to skilled people who can help you do those things, or it could just be, I want fully corrected data sets for doing those things as well. So, all right, I'm not getting too much engagement with that, and I'm also keeping track of time. So what I might suggest we do now is I'm going to hand over to Megan so that we can probably split into smaller groups and have a bit more of a chat about this to try and pull it apart a bit more and understand it. Megan.
Thanks, Stuart. Yes, so we have a 5-minute informal session. You could think of this as going to get a tea or a coffee at a conference and chatting to somebody. You've been put into small groups with other webinar participants and also the speakers for today. No agenda or formal reporting back, but just a chance to meet some of the other people who are in the webinar today, introduce yourself to each other, and to share your expectations and interest in the topic. What are you hoping to get from the session? So over to Larissa, who I think has organised the groups, and we'll push the button and make it happen. Thank you.
What we're going to do now is switch over to our panel and go through a series of questions, given they're the ones with the expertise in this area. And before we do go into the panel, I'm going to introduce them, and we're going to ask them about the analytics hubs or services or facilities that they actually provide, and then look into the future as well. And the aim of doing that is to sort of set us up to look into next year, where we're going to continue to do this sort of community building work and leading to our forum in August 2022, will there be a much bigger coverage of this? So I'm just going to introduce everybody quite sort of briefly. There are longer bios. So what I might do is for each of the panel members, if I can I'll do a really brief introduction, but if you could just let me know, what's the key point, about you and your facility that you want to get across today really quickly, that would be good. So the first person I'm going to introduce is Professor Melanie Johnston-Hollitt. Melanie is currently the director of the Australian Space Data Analysis Facility at Curtin University in Perth. She has quite an extensive academic and scientific background. But Melanie, what's the key point about ASDAF and yourself?
Well, the key point about ASDAF is that I want to have people understand how to access it and how we can help them use space data. And the key point about me is I come from a background in radio astronomy, so I've been looking out and not down. So this is pivoting my skill set.
Cool. I think that's a really important point, and that's one of those pivots we want to make both ways with this. Thanks very much, Melanie. Next is Dr. Robert Woodcock from CSIRO. I guess Robert's official title is CSIRO Research Consultant in Earth Analytics Infrastructure, and I know I can go to Robert to solve a lot of the problems I have in this space. Robert, what's the focus of EASY and yourself here?
Really, just EASY's focus is really to accelerate the innovation lifecycle, make Earth analytics more accessible to more people at a far greater scales than we've ever been able to do before, to really help tackle some of the global problems that we're all facing. So yeah, that's why I'm here. That's what this is about.
Cool. Thanks, Rob. Okay, next up's Trent Kershaw from Geoscience Australia. He's the Director of Business Development at Digital Earth Australia. Trent, what's the key point in terms of DEA and yourself for today?
Thanks, Stuart. For Digital Earth Australia, the big thing for us is to lift the baseline as much as we can for everyone and remove the barriers that we know exist at the moment that are preventing people from embedding satellite imagery and data into decisions.
Mm-hmm. Thanks, Trent. And last but not the least, so Sebastian Chaui from Alula. So Sebastian's the co-founder and CEO of Alula, which is one of our new space startups. And Sebastian, key points from Alula and yourself for today.
Thanks, Stuart. Yeah, my name's Sebastian. And at Alula, what we do is we reduce the time it takes to order and purchase high-resolution commercial satellite imagery. Typically the experience of buying satellite imagery from many of the major vendors, it can take weeks, and we reduce that down to only a few hours or a few seconds. And we do that through our API, essentially. So we've built an API and a lot of backend infrastructure that allows people to stream high-resolution archive satellite imagery from any point on the world, essentially, or any point around the world, sorry. So yeah, that's sort of what we do.
Right. Thanks, Sebastian. So what we're going to do now is going to put a question to the panel, and everybody will have, I guess, up to 3 minutes to talk. I'll let you know when you've got 30 seconds left, and then we'll finish off at 3 minutes. So, and I'm happy to remind everyone of the question. So the question is, how do people engage with analytics hubs or services, and what will they get from that interaction? So Melanie, if we could start with you and ASDAF, please.
Yep, sure. Thank you, Stuart. So ASDAF is a facility that was set up about a year ago now by the Australian Space Agency, DISA, and the WA state government. And our role is to help researchers and SMEs unlock the value of space data. So we've got 3 delivery partners. So the Curtin Institute for Computation, which is where most of the team are based here at Curtin University. And I'm the director of the Curtin Institute for Computation, which is a data science institute. The Pawsey Supercomputing Centre, which provides access to supercomputing resources, and the WA Data Science Innovation Hub. And what we do is we provide SMEs and researchers access to data engineering, data analytics, data science, and also training on accessing space-based data, which includes Earth observations, and also an extensive set of online resources on the website. So what we're looking to do is partner with people and help you unlock the value of space data. So if you want to have a data scientist come and do a piece of work that we can do through a funded program, we have expressions of interest on our website open at the moment for round 2, which closes on the 14th of January. So if you go to asdaf.space, you can find an extensive form, you can fill it in, it'll allow you to say whether or not you're looking for specific training in how to access data, how to utilize data, what data are available, or if you want to get in touch with us to talk about scoping out a project to work with one of our data scientists or engineers to help you utilize space data in your products and research. And that's it.
Excellent. Thanks very much, Melanie. Definitely within the time limit. And what we'll do as we go through is also, if anyone mentions links like the ASDAF link, we'll put that into the chat window so people can access it. And there's a record with, I guess, the presentation as well. So next in line, I guess, Trent, back to you again. How are you going to help people, engage more effectively with DEA, and what are they going to get out of that interaction?
Great, thanks, Stuart. And so in terms of what DEA is, it is an Australian government program that has been funded to equip government, industry and communities ultimately with free and open satellite data. As a part of this, we've done a lot of work in going out and engaging with our government partners, with industry, to better understand what the barriers are at the moment. And in short, they are many and they are varied. Our goal is to try to overcome as many of the barriers as possible and provide that higher level of starting point for everybody. So whether that is in using free and open satellite data from the Landsat program or the Copernicus program, the Sentinel satellites, our goal is to try and make it as easy as possible to start using Earth observation data. So we invest in trying to remove as much of the atmospheric noise out of these data as possible, and produce data sets that we call analysis-ready data, also known as surface reflectance, that hopefully means that you're in a position where you can use this time series of over 30 years of satellite data as a statistical data set. That's a fundamental part of the stepping stone we need to make. But equally, there is a software component to this, and that's why Digital Earth Australia invests heavily in the Open Data Cube community. So there is a GitHub project called Open Data Cube. Rob might speak to this a little bit as well in his talk, but the goal here is to just lift that baseline. Where do people start when they're going on their journey of trying to integrate Earth observation data into their work? So this is really what we're about. In some ways, our goal is to rather than just be a platform, be a part of many platforms as well. I think I don't want to get into the second question you're going to ask, Stuart, but I think it's a really important point that people are making decisions in all sorts of places, and it's our goal to make sure that our data, but also other Earth observation data, finds its way into those systems that people are using to make better decisions. And I'll stop there.
All right, thanks, Trent. Just within time there. So again, over to Rob for the next one. How to, and I'm not sure if this is a focus on EASY or Open Data Cube or both, but how do people engage with those, and what are they actually going to get out of engaging with those?
Thanks, Stuart. Yeah, so at CSIRO, we operate a thing called the Earth Analytics Science Innovation Hub, or EASY for short. In fact, we operate more than one EASY, for reasons I'll go into a little bit later in this particular answer. EASY is a highly scalable, on-demand, cloud-native environment with an emphasis on Earth analytics. And as Trent pointed out, it has a common element in the open data cube for performing a lot of the Earth observation data processing, but it does go well beyond that, as does Digital Earth Australia for that matter, including libraries for machine learning and for advanced workflow operations and scalability across computing environments. So it's very heavily hooked into the Python data science ecosystem to enable that, and the Open Data Cube is a critical part of that for Earth observation. There's also a range of features in there. The one that I like to emphasize the most actually is that every user of this system can have their own personal compute cluster. In fact, they can not only have their own personal compute cluster, they can have multiple personal compute clusters. And the reason this is really important, I think, in this environment is you don't need to wait your turn like you do in a shared facility. And everyone gets what they need when they need it. There is a limit, ultimately, somewhere, but that limit is so far up and beyond the current projects that we have running in the system that it's practically irrelevant at this point in time. And this enables a whole range of problems and scientific analysis, and really just accelerates the innovation life cycle associated with working with and playing with Earth observation data. To put that a little bit in perspective, I've just completed a work for a very large company where I was routinely and interactively using a 4,800 core cluster just by myself to process a 40-year archive of Earth observation data set across a third of the US continent. And it takes only 20 minutes to do a run. So I can do that multiple times in a single day, just me, without interfering with any of the other users in the system. Personally, I find that absolutely astonishing, and it opens up a lot of doors. So the impact really is that acceleration of the life cycle. We've even had groups receive productivity awards for delivering projects using the EASY system just within CSIRO and getting it out faster. Now, that's the CSIRO experience, but we actually operate EASY for industry and government, and we have deployments in other countries. I'll mention Southeast Asia particularly because it came up during our breakout session. So we actually operate an EASY in Southeast Asia as well. So if people are interested, they should give us a call. Thank you, Stuart.
No worries. Thanks for keeping the time, Rob. All right, Sebastian, over to you now. You know, from an Alula perspective, how do people engage with this, and what are they going to get from that interaction?
Thanks, Stuart. Yeah, so I feel like a lot of data analytics hubs today have this really unique opportunity to essentially engage and educate a new sort of group of people that probably are less familiar with geospatial science and remote sensing. I believe that data analytics hubs for remote sensing and Earth observation play a key role because they can actually draw in people and have them starting to understand the impacts of satellite imaging and the usefulness of it in new applications. And I think going on from that as well, I also believe that the industry itself is kind of changing. So a lot of how people would use this kind of data in the past was around essentially sort of doing projects, a lot of project-based work. But what we're seeing now, this sort of nascent group of people developing scalable applications out of EO data. And at Alula, we find that incredibly exciting because that means that these applications are very use case specific. So they might be in ag tech, they might be in finance, construction, they might be in environmental science, could be anything really. But they've created a scalable pipeline out of a data analytics hub, and they're presenting that data or that information along with a number of other data sets in order to create insights for users. And so really it's sort of twofold I see these analytics hubs playing. It's the education angle for new people, Because right now I feel like the sort of the spatial sciences world, the geospatial world is kind of hard to get into for newbies. And then the other angle is also, I guess, helping people scale out new EO applications as well. So I think there's sort of really sort of two benefits from interacting with these kinds of hubs.
Well, thanks, Sebastian. And I think that's a really succinct way to, an effective way to bring that together. And it actually does neatly pull together, you know, across sort of Melanie, Trent, and what Rob has said there. I mean, that education angle is quite important because, you know, people building activities are not doing it because they want a certain data set, they want to solve a certain problem in that context. So thanks very much for doing that. Okay, we're going to move on to the second question now, and then we'll try and pull things together towards the end of it. And I know Trent's not exactly looking forward to this question, but this is something that occupies, I think, a lot of people's time at the moment, particularly thinking in a strategic sense, whether it's in I guess our state and territory governments, our Commonwealth, our larger companies who are looking forward 2 to 5 years and saying, okay, in terms of training people, what we're investing in now, what is it that we're working to know, over the next 2, 3, 5 years, and where are analytics hubs going to be in that time? Are they still going to be here, in this form? I mean, that's something to think about, because if you look at Google Earth Engine, if you look at AWS services or Microsoft's planetary computer, all of the other activities, they have changed over the last 2 to 4 years, but have they changed that much? So I'm going to change the order around a little bit. And Trent, I'm coming to you first with that question.
Typical. Thanks, Stuart. Look, I mean, from my perspective, yeah, to answer the straight question, are there going to be analytics hubs? Yes, absolutely. Of course there are. In terms of what we do, so we are, very much focused on Earth observation data, satellite data in our case, and what is in almost every situation the case is that is part of the picture. That is part of the data that you need in order to make a decision or to advise somebody on how to make a better decision. So what I think we're going to see more and more of is mission-based analytics hubs, where it's very much about what particular sectors are looking to do. It's not going to be an EO analytics hub necessarily. It's going to be far more down the lines of a climate risk analytics hub, or it's going to be whatever it might be. It's going to be about the actual user problem rather than about what we often talk about in terms of just Earth observation. So I think that's the message I'd send, that I think that's where it's going. Thank goodness for the advances in cloud infrastructure from the big players here. They are effectively gigantic analytics hubs that are helping us to have all of the data in an environment where you can get compute alongside all of these data sets and ultimately pull them all together and make better decisions as a result, and make better assertions, make better models as a result of having all of that data and all of that compute together.
Thanks, Trent. Melanie, if we could go over to you now. I mean, Trent's come from the Digital Earth Australia perspective and the cloud perspective. As a nation, we still have a very significant investment in large-scale compute in a range of facilities. So, in that context, given the question, where do you see that, the large-scale in place compute and cloud and moving forwards in future.
Yeah, so I mean, I'm director of ASDAF, but my other job is director of a data science institute, and I get asked this question quite often. And we're agnostic as to what compute we use for whatever problem is that we're trying to solve. So we see a need for small base clusters, large scale infrastructure like the Pawsey Supercomputing Centre, and then the cloud-based stuff. And so I really think that that ecosystem is going to persist, but with more targeted use cases. And as I said at the start, my background's in radio astronomy, which is a field that requires you to have very large scale compute close to the actual source of the data. And so for us, cloud-based solutions aren't going to cut it. So it really just depends on the application you're using and the appropriate selection of compute. So I see that as a continuum, and people should use the tool, which compute is, for whatever purposes they're trying to do. I think the other point that I would like to sort of raise is, as director of a data science institute, data science is absolutely exploding in all different dimensions. And we're seeing really amazing and novel workflows and processes coming forward from data science. And that's in every field, including Earth observations. And I think one of the really fascinating things that we're going to see in the next few years is where people start to combine data sets which they haven't really thought of combining before to get better insights. So ground-based data sets with space-based data sets. And we're working at the moment with ASDAF with a company here in Western Australia who make precision optical measurement devices for turbidity and things under the water. And what they're working with us on is taking space-based observations of the sea and using their sensors to make a value-added product where the data sets, the space-based data sets, are actually validated from in situ observations. And I think we're going to see more and more of that really unique combinations of space-based data with terrestrial data gathering. And I think you use the compute that's appropriate to use it. And I think Australia should continue to invest in compute at a national scale for the purposes that we need it for, but also be open to using cloud-based services where they're warranted. So I could talk about this for ages, so I should probably stop there and let somebody else have a go.
I think we can all, it would be good to have, and that's why we're trying to, this is essentially sort of a teaser for what will happen next year. And this is a much bigger discussion, so I'm really glad you got to that point. And that continuum is a really critical one. And the integration of the different data sets. And I mean, you've mentioned the astronomy data and space situational awareness data, aerial imaging systems and drones. Are another example that fits into that space, and it often cloud doesn't work for that. So yeah, okay. All right, let's keep going, because I do want to leave time for some questions as well. And we can head over to Sebastian now. And where do you think things are going in the sense of analytics hubs and in that sort of 2, 3 to 5 year period?
Yeah, that's a good question, Stuart. I think that analytics hubs is just to sort of concur with Trent and Melanie already as well. I think that they're going to still be around, and I think that they probably will change. And I think they'll change based on a lot of, I guess, how new players start to use them. Because I think what we've done is we've responded to, I guess, existing demand and existing needs. But as new organizations start to clue into the usefulness of Earth observation data, just sort of like as Melanie's because client, as might be the best word, the turbidity sensor company, as they've started to realize, oh, hang on, we can actually do something really, really interesting here. I think that new demand will drive, I guess, how these kinds of hubs change as well. And at Alula, we certainly respond to that as well. I think we really sort of started to see early on that we wanted to start to support this emerging class of application developers who are building these very niche specific apps. And we built our platform to respond and to cater for them as well. So I think I couldn't possibly say what they'll look like in the next 5 years' time. I don't have a crystal ball, but I do think that they definitely will change. And maybe as to what sort of Trent said as well, he alluded to, he said that they might become more use case specific or even industry specific as well. And so I think that's definitely a potential there.
Thanks very much, Sebastian. I think that's a good lead into to Rob, and I guess so. 3 years from now, Rob, I mean, is easy still there, or is it's just embedded in all these other things? I don't know.
Easy will be everywhere. It's my retirement plan.
It's ubiquitous.
That's right. Now, I think the challenge we have with hubs really is they can tend towards a particular opinion about how things should be done. All right, and when you do that, you actually stifle innovation. All right, and so you end up. That's why standards become more standards, right? It's because ultimately there's a stifling of innovation, and you can't change unless you update or tweak something. What I really think we're seeing is a radical alteration to the value chain associated with Earth observation data. Groups like Geoscience Australia, CSIRO, have been influencing the Committee on Earth Observation Satellites around the generation of analysis-ready data and the use of cloud for the distribution of data, right? The result of that is you have 3 major planetary clouds running planetary data sets accessible to anybody that wants to get on there, right? And if you've got the budget for it, you can process all of it. I mean, it's astonishing. And when you've got that level of change occurring in the system, it opens up new opportunities, and you get groups like Alula. They're a niche provider in that value chain, which they could not have done before, right? And we're seeing this all the way across the value chain. Commercial rockets launching, CubeSats have changed the way in which you can launch sensors. You can have a nice specialized custom sensor just because I want. Heck, I could just about do one from my house mortgage, right? It's just insane, all right? So with that massive changeover in the value chain, I think it opens up opportunity for innovative new businesses, even small ones, to grow up and generate things. They could literally go from paddock to planet scale during a startup phase. So there's plenty of opportunity for new business, plenty of opportunity for new decisions, opportunity for government there. I think we definitely not going to see one hub to rule them all. That would be bad. That's why CSIRO doesn't operate one hub to rule them all. We have them in region for sovereignty reasons. We have them in region for support reasons. All right. There's reasons why you have multiple of them. So I think we'll see 2 to 3 years, we'll see some of the same architectural elements of the current hubs, but with a greater personalization, greater participation. And my hope would be, given the things we're tackling, far more efficient sharing of data and infrastructure and technology, so you can move between these without causing, well, more hair loss in my case.
Thanks very much, Rob. Thanks, everyone. What we might do now is just go to questions from the audience, and once we've gone through those, we'll essentially summarise things and move forward. But I think thanks very much to Melanie, Rob, Trent, and Sebastian for all of that input. It really covered a broad range of thoughts and things that I think some of us haven't considered as well. So I'll open the floor to questions now. If we could ask people to type questions into the chat window, and then we'll go through them that way and try and answer them as best as possible to begin with. So yeah, have a go at questions now, but I do think the point that we've landed at there in terms of some of those key things is we're not going to, and I do like there's not going to be one hub to rule them all. That also comes from there's never going to be one data portal to rule them all type thing as well. That this is, it's an opportunity to move to more question and problem focused approaches in terms of solving things. And that also lets us develop, more industry and applications around it. Question from Angela, which I think is to Rob. For easy, what about privacy and intellectual property? Can you use that service, without publicising the work that's being done?
Yeah, so we actually offer easy as a couple of commercial offerings. We actually have an easy subscription service used where we CSIRO host the system and make it available to users, but users are isolated from each other. We do in fact have users operating with very private data. They have their own intellectual property. The only people that can ever see any of that is the admins. Nobody else can see anybody else's, and there's a whole rules of engagement associated with that in the agreement. So you can do that. For those that have even a stricter requirement or a desire for a larger system, we actually have an easy enterprise agreement where you can actually deploy to your own cloud account, integrate directly with your own systems. And we use that with, we actually have it working with a Fortune 500 company who use it with their internal systems to really expand stuff. And we get to do R&D with them, which is even better as well. So that's great for both groups. So yes, you can use the service without publicizing the work and work that's being done, and you can be quite private around what you're doing.
Right, thanks, Rob. Question from Stephen Ward, which is actually to everyone. So, with the Open Data Cube, Digital Earth Australia, and a lot of other things, Australia's been ahead of the curve in this area for a number of years, even before that. But with Amazon, Microsoft, Google Earth Engine, and others pushing hard, how do we maintain an advantage in this space? And anyone can have a go at that.
I'll go, and then we'll see who else has something to say. And I guess I want to start with where ODC started in this, and that is that in line with what I said at the start, we're about removing the barriers that exist to people using this stuff and gaining some sort of insight out of satellite imagery. So we worked in that space because there was a gap. If there was no gap, we'd be doing something else because it's just not innovative to reinvent things that are already invented. So that's why we worked in that space. The great thing about being ahead of the curve as Australia is at the moment is that that all of us, the EO industry in Australia is in the perfect position to take advantage of Australia being ahead of the curve and develop further technologies, engage with users in Australia, but engage with users globally as well to come up with new innovative solutions to real world problems. So I think that's where I see things going, that really, we're working in this space. It's all building blocks, right? And especially for Digital Earth Australia, everything we do, we go out of our way to make open, because it's all about those building blocks that we can create that help everybody else to succeed. So I might leave it there, but I think it's really important that we look at now, how are people going to use this great technology that we're all working together on?
Yeah, if I may add to that, I think the important thing about a lot of the work that the larger cloud organizations do and so forth is it's actually about undifferentiated heavy lifting, right? ODC is about the undifferentiated heavy lifting in a niche part of the overall value chain, right? The part that really actually causes you to have competitive advantage is the value add on top of that. It's taking the stuff that's the gray matter that's inside, well, some of those other heads, not necessarily this one, and applying it to creating better decisions or managing our planet or selling really whizzy products that make commercial data more accessible. It's about that value, right? The clouds make tech more accessible, and in a lot of places they are totally undifferentiated. There's nothing to pick between them. You can use any of them, right? But there are niches where they have value and they value add, and that's how we maintain our competitive advantage. It's by doing that better, which I think is where Trent's getting at it. That's if we are ahead of the curve on some of the tech. We have a much better understanding of a lot of the value chains. We've been influencing it heavily for the last few years from Australia internationally. It's made a difference. Let's build on it.
Thanks, Rob. So I want to sort of jump a bit sideways. Melanie, you raised a point earlier that comes into this advantage space, which is, you've got sort of, scientific career looking out into space. What are approaches that we can take because Australia is a world leader in that area, so that, you know, Earth observation can learn from that, and that, you know, Earth observation could contribute to that as well.
Yeah, so one of the really interesting things for me coming in from the field of astronomy to Earth observations has been the amount of data engineering and cleaning that has to be done before you can get to an analysis-ready data set. So one of the points that I've raised previously is that the international astronomy community has spent 40 years coming up with standards to allow you to port data sets into different analytics tools seamlessly. So this sort of comes back to points that have been previously raised about how do we actually leverage all this stuff collectively to get better outcomes to decisions faster. And one of those things, I think, is a lesson that we can take from the astronomy community about how you do that and how you can make sure that your data can be ported from platform to platform. While I do take on board the commentary that, you know, you won't have one size fits all, which is absolutely true, it's nice to be able to be an astronomer and go to a portal and download data from any part of the electromagnetic spectrum and know that I can open it in a viewer and overlay it, and not have to spend like 3 weeks of a data scientist's time to clean it up and make all of the standardization the same, just to do the simple things. And so I come from a world where I'm used to going, oh yeah, there's an object that emits across the spectrum, so like hyperspectral cubes.
Mm-hmm.
I will get all those data, download it, and just load it up and get insights immediately into the physics of what's going on with that system. Whereas for Earth observation data, there's this protracted sort of lengthening of the time before you get to that, because you're doing these sort of things which I think we could shortcut if we could develop standardization tools and data sets. So that's the biggest thing I think we can take from astronomy. The other thing I think is the Australian astronomical community is extraordinarily collaborative and organized. And I think the Earth observation community in Australia is like this as well, but the degree to which the Australian astronomical community has influenced government is quite astonishing. So we're now in a situation where the government hands money to a company by limited guarantee made up of the astronomy community, who then dish it out themselves. So we don't go through competitive processes there. The community comes together as a whole and decides on the priorities for spending in the sector. And that's, I think, also a really interesting position to have got into as a scientific community. And if there's lessons to be learned from that, I think that would be useful to translate as well.
Thanks, Melanie. Right, I'm just conscious of time. That last point is something that a number of us who are on this call is a very important one, about helping us work together as a community. And we've tried to learn from AIS, and I think this has pushed it to the next level of being able to do that. So thanks for ending on that point. I'm just going to finish off there in terms of running the discussion and hand it back to Megan Lewis to finish off today and say thanks everybody officially. Megan, back to you.
Thank you. Well, firstly, thank you everybody who's joined the webinar today and participated. I can see around about 60 people who've joined. Thank you very much to our expert panelists. We've clearly only just touched the surface of things that we can discuss with you and what you have to share with us. And I think there have been some really stimulating ideas there that we can carry forward into our interactions and conversations, and may well become themes and topics that we deal with in the forum. Stuart, thank you, and thank you to the directors of the Advancing Earth Observation Australia Forum for the concept of these webinars to lead up to our main forum, and the Management Committee of Earth Observation Australia for their input in topics and ideas. And thank you to Larissa Marfan, who's been pushing buttons and stage managing and liaising with everybody to make this happen, and Sylvia Michael of the office for support in doing that. I think Larissa will send around information about how you can give us some feedback, because this is the beginning of a series of webinars, and we look forward to meeting you, seeing you in our future ones. Please keep an eye on our webpage and your inbox for news about them over the next 6 months or so. Thank you very much, everybody. Goodbye. Thank you.